Hi everybody, it's Mrs. Mancuso. I miss you all. This video is on acids and bases and it's all about titration. So I've got up on the screen, titration is a neutralization reaction. So we've already done a little bit of this. If you take an acid and a base and they react together, the acid's going to have a really low pH, the base is going to have a really high pH, and you neutralize it. You bring it closer to 7 when you put them together. The reaction usually gives you an ionic compound, so like a salt, and water. So now I'm going to show you how you actually do this in a lab to figure out either the molarity or the volume of your acid or your base. So I'm going to draw for you a little, this is called a burette, and it's a tube and it has a point like this, and it has a little stopper. Whoops, not sure why that happened. There we go. It's got a little thing like that. And this is going to be able to turn it on or off. And then on here are all little graduations. So you can measure how much liquid you're letting out. So the liquid comes out right here. And then underneath it, you would have a flask. Wow, I really am terrible at drawing. Okay, so let's say up here, this is my acid inside of this. And then down here, I put in a specific volume of a base. So let's say my base is sodium hydroxide, and let's say it's 1.0 molar. All right, and the volume of it, let's say we've got 10 milliliters of it. And up here, let's say I start with 50 milliliters of acid. The first thing you have to do before you even start this lab is you have to put an indicator in here. And the indicator will change color, just like all those indicators on table M. They'll change color when you change pH. So you'll know that it's done by the change in color. So it's really important you remember to add your indicator. I'm actually going to have you do a virtual lab of this, which is pretty cool. So you add this acid. So the acid drips in and it neutralizes the base. And when eventually this changes color, you stop. So you turn this off and you measure how much it went down. So let's say this is the ending point and it went down to 20 milliliters. So if you subtract 50 minus 20, that tells me 30 milliliters of the acid was used. So now let's think about what I have in terms of doing a calculation. This is the volume of the acid. This is the volume of the base. And over here, this is the molarity of the base. So the one thing that I need to know, the one thing that I'm solving for, is the molarity of the acid. That's going to be my X. So we'll go down here and we'll do the math. So molarity of the acid times 30 is equal to 10 times 1. Divide this side by 30, divide this side by 30. That tells me the molarity of the acid is 0.33 molar. All right, so that's how you do a titration problem. Let me move on to the next slide. There's the formula that we just used. So lots of times it's just written like a titration problem, and you're using that formula right here from table T. So there's our formula every time. All right, so let's do another one. I have 60 milliliters of 2.0 molar HCl. Well, right away, I'm going to mark for myself that that's the acid. And how did I know it was the acid? It starts with an H, so that gives it away. I could look on table K, and it's listed there as hydrochloric acid. And this one, when you have a metal with an OH, you know that's a base. So this is the volume of my acid. This is the molarity of my acid. And this is the volume of my base, simply because I know milliliters is a volume reading and molarity is molarity. All right, so I'm going to solve for the molarity of the base. So I have 60 times 2.0 is equal to 30 times MB. Divide this side by 30, divide this side by 30, and I get the molarity of the base is equal to 4.0 molar. And you'll notice I did keep my sig figs. I've got 2 sig figs here, and so I used 2 sig figs in my answer. All right, let's go on to the next one. 126 milliliters of 12 molar HBr. So again, starting with H, that's my acid, and a metal and an OH, that's my base. So I've got the volume of the acid, the molarity of the acid, and the volume of the base. So 126 times 12.0 is equal to 274 times the molarity of the base. This time I'm going to want 3 sig figs because all these numbers going in have 3 sig figs in them. So divide this side by 274, divide this side by 274. These will cancel out. The molarity of the base is equal to 5.52 molar. All right, you getting the hang of it? I did do my math ahead of time. So if you see me like looking over to the side, I did my calculations. Next one. What volume of 4.5 molar HCl is needed to neutralize 35.2 milliliters of 2.8 molar LiOH? So LiOH, that's a metal and an OH, so that's my base. And HCl, that's my acid. They gave me the molarity of the acid, the volume of the base, and the molarity of the base. So what I need is the volume of my acid. So Va times 4.5 is equal to 35.2 times 2.8. Again, I want 2 sig figs here because I'm looking at the numbers and which ones have the least. So divide this side by 4.5, divide this side by 4.5. The volume of the acid will be equal to 22 milliliters. All right, next one. We're rolling right along here, people. H2SO4, that's my acid, and 18 molar, so that's the molarity of my acid. Here's my base, so that's the volume of my base and the molarity of my base. So I've got Va times 18.0 is equal to 155 times 12.0. Now, if you find at any time that I'm going a little bit too fast, just pause me, set up the calculation, do the math all yourself, and then play me again and see if you got the same answer I got. That would definitely be my recommendation. I do have a practice sheet that you are going to do as soon as I'm done with this video to make sure that you go through a bunch of problems on your own and that you can solve them all. So this time when I did the math, I got 103 milliliters, and all of these had 3 sig figs in them. All right, next one. What concentration of H2SO4, so H2SO4 is my acid, if 65.5 milliliters of the acid, so that's my volume of the acid, neutralizes, this is definitely my base, a metal with a OH, a hydroxide. This is the volume of the base. This is the molarity of the base. All right, so I'm going to solve for Ma. I multiply that by 65 equals 110 times 8.5. The nice thing about this unit that you're noticing, there's only one formula. So there's only one way that you solve each of these. And my recommendation is always to write all over the question and write in those VBs and MBs just to keep yourself knowing what each value is and what you're looking for. So the molarity here of the acid would be 14 molar, and I used 2 sig figs for that. Next one. Okay, so now sometimes the questions are like what I just did, and sometimes it's much more explaining the lab to you. So that's why I'm going to have you do this lab virtually to make sure that you're understanding like, oh, hey, I have this big glass tube and I'm adding an acid to a base that's in a beaker or a flask, and I'm waiting for my indicator to change color. And when it does, it will have neutralized it. So I want you to think about the student starts off with 30 milliliters of vinegar, drop by drop. So here is my vinegar up here. And I started with 30 milliliters. So 30 milliliters is my starting point right here. And she adds it drop by drop to 10 milliliters. So here's my 10 milliliters of 2.0 sodium hydroxide. So Na is a +1, OH is a -1, sodium hydroxide would be NaOH. So when the indicator in the vinegar turns pink, the student noticed that 11 milliliters of vinegar remain in the burette. So you got a picture. Here was my burette full of it. I don't know why I keep doing that. It keeps erasing. But it was all in here. And she let it out drop by drop by drop until she got to the 11.0 line. When she got to the 11.0 line, this had changed color. So once this changed color, she stopped. So the first thing we have to do is calculate the amount that she used. So 30 minus 11, that tells me she used 19 milliliters. So this is my volume of the acid. So I have to subtract to figure out how much she used. Now I can do all my math. So I'm trying to solve for the molarity of the vinegar. I know I used 19 milliliters of it, and I had 10 milliliters of the base, and it was 2 molar. So divide this side by 19, divide this side by 19. I only have 2 sig figs here, so the molarity of my acid is equal to 1.1 molar. All right, let's try a couple more. Again, a lab setup. A chemistry student starts with 50 milliliters of vinegar. So I'm going to draw my little setup. So we're going to start with 50 milliliters of vinegar. And I know vinegar is an acid. Vinegar is acetic acid. It's actually on table K. So I'm going to add this to my base, and drop by drop, she adds it to 25 milliliters of 2.0 sodium hydroxide. So down here, I have 25.0, so that's the volume of my base, and 2.0 molar. So here's my base. That's the molarity of my base. When the indicator in the vinegar turns pink, the student notices that 13 milliliters of vinegar remain. So she let it out until the 13.0 point. So you do the math. This minus this is going to give me 37.0. So that is the volume of my acid. And then I set up my calculation. MA times 37.0 is equal to 25.0 times 2.0. Divide this side by 37. Divide this side by 37. I'm going to want 2 sig figs. And I get 1. The molarity of the acid is equal to 1.4 molar. All right. I have one more problem for you. A student sets up a titration to test a calculation that she does in class. She puts 50 milliliters of 4.5 molar HCl in the burette. So let me draw that. Here's my burette. It's at 50, and this is HCl, and it's 4.5 molar. And under it, she's got a beaker, and in there, or a flask, 15.0 milliliters. So this is the volume of my base, and it's 3.0, so that's the molarity of my base. What does she expect the burette's remaining volume of HCl to be when it's complete? So they're asking you, when this goes down, what's the final number going to be on your burette? Like, how far will it go down? So you actually do all of your math first. So the molarity of my acid is 4.5. The volume of the acid is what I'm trying to find, times 15.0 times 3.0. Divide by 4.5, divide by 4.5. So the volume of my acid, the volume of my acid comes out to be 10 milliliters. And I put a decimal by it because I want it to have 2 sig figs. So when you get a 10, to show that that 0 matters, you have to put a decimal there. But that's the volume of my acid, but it's not my answer. The answer says, what's my final reading going to be? So if I started at 50 and I use 10, my final reading is going to be 40 milliliters. So my answer, the burette, will be burette will show 40.0 milliliters of vinegar left. All right, so I hope that that made sense to you. I hope that you understand it. Feel free to ask me questions, and when we Zoom later this week, you can ask me any questions from the problems that you do. So make sure you do the practice sheet that comes right after this video. Bye, guys.